everyone, welcome back to the Tech Mapper again. In today's video, we are diving deep into one of the most important Spark optimization technique, which is the most asked interview question, the difference between the cache and persist. Cache and persist are both used to optimize the Spark job and used to store the data frame or RDD into the memory and other storage levels. We will see one by one. So let's go to the cache first. Cache is used to store the intermediate result into memory, which is frequently used into the same Spark job. By storing the intermediate data frame into memory, we are avoiding the recomputation of the data frame. So if that data frame is used multiple times in the transformation, so Spark will not compute that data frame again. It will directly use the cache data frame from memory and reduces the execution time of the entire Spark job. So cache method store the data frame in memory only, which actually fits in the memory. So whenever we are actually using the cache method and to store that intermediate result into the memory, cache will not directly store the data frame into memory until an action is called, like count, show or write. So, and as you can see on the slide, the syntax to store the data frame into memory, we have to just give the dot cache after the data frame name and store that into the another data frame name. In this example code, we have read the file from AS3 and filtered the data and stored into the filter df. So we have filtered the data according to the column name as a department and equals to the IT. So it will filter the data according to the columns. So that data is actually gets saved into the filter df. But in this situation, if we are not using cache method here to store this filter df into the memory, so whenever there is this filter df is actually reused multiple times into the another transformation, Spark is actually going to recalculate this filter df again and again whenever there is required. So whenever there is action is called, so it will recompute the filter df again and again. So what happens here? So it will actually make our Spark job very slow and it is a very time consuming process. But when we cache this data frame, that is filter df, into the Spark memory, so what will Spark memory will do? It will actually reduces the computation time, but it also do not recompute this filter df because it is actually getting stored into the Spark memory. So it will directly uses that cache data frame from that memory only, and it actually saves our recomputation time and optimizes the Spark execution time of our job. So whenever there is one more point to take a note of that. So whenever you are using the cache method to store the intermediate result or an intermediate data frame, which is important data to be stored into the memory, so that data should be fit into the memory only. So the size of the data should be fitted into the memory. To store the data into the memory, there must be an action called after the cache method to be called. Cache is considered as a shorthand for persist because persist have a default storage level as a memory only. So we can consider as a cache as a shorthand for persist. Now let's talk about the persist. Persist also stores the intermediate data frame or the result into memory and other storage levels such as memory only, memory and disk, memory only serialized, memory and disk serialized, and the disk only. So in memory only storage level, so data is actually getting cached into the memory in the non-serialized format. So whenever, what is the non-serialized format? Non-serialized means it is in object format, and it actually takes the more storage. Whenever the data is getting stored onto the memory or the disk, it actually takes the object format is actually taking a more storage to store the data onto the memory or to the disk. And when considered about the serialized means it is actually into the bytes format or into the binary format, and it actually takes the less storage onto the disk or onto the memory. So let's say when the data which is going to be stored onto the memory, so if enough memory is not available to store that data, so it will not give the error, but it will actually skip the remaining data, so which cannot be saved on that onto that memory. So that whenever that remaining data is not saved onto that memory, so whenever there is an action is called and that data frame is actually getting reused, so whenever the action is called, it actually recomputes that data again. So this is the problem into the memory only storage levels. When the data is not enough, when the data is it actually not getting fit into the memory. Now let's move to the memory and disk. So memory and disk is the common choice for the large data frame, which is safe and the balanced type, we can say that. So the data is cached in memory, and whenever there is enough memory is not available, so the sum of the blocks from the memory are getting serialized to the disk. So the sum of the data is actually getting stored onto the disk. So this mode of operation is recommended. So when the revaluation is expensive and memory resources are very limited. There is a third storage level which is into the persist, that is a memory only serialized. So it stores the serialized data into memory, which is into the binary format, so it actually takes the less storage. The fourth one is memory and disk serialized, which actually store the data into memory into the serialized format, and enough memory is when the enough memory is not available, then the data is split or spilled into the disk, so that half the data is saved to the disk. Other format storage level, which is disk only, the data is completely stored onto the disk only in this storage level in the serialized format. So the data will be always read from the disk, and which is the slowest storage level, but it actually safe for the large data. So there will be a sixth of the storage levels, means there is a off heap memory, which blocks are cached off heap, means the outside the JVM. So outside the JVM means Java virtual machines. Outside the Java virtual machines, the memory is actually taken was borrowed from the, it actually grabs the piece of memory outside the executors and it stores the data on that memory, and it actually uses the tungsten of heap memory. We have seen the various storage levels, means for the persist. So this is the syntax for the each storage levels, how to use as a storage into the persist levels. So we can just say that or write df.persist, give the storage level dot and the storage level name. That is only if we are using the memory only, so we just give it as a memory only. After that we have to give the memory and disk, and whenever we have to use the memory only serialized, we can give the memory only serialized, and after that we can whatever it means we have to use memory and disk serialized, we can give that also. And if we are want to use the only disk only storage level into the persist, so you can just give the df.persist storage level dot disk underscore only. This is the off heap syntax to store the data into the off heap memory. So we are just taken as a data frame name dot persist storage level and dot and give the off heap just the keyword, so it will directly store that data into the off heap memory. If you like this video, do share with your friends who is essentially need it, and subscribe the channel for more videos. For some time I was unable to post the video, but we will continue with the Spark optimizations in a very deep, so you will get the complete understanding so how to speed up the Spark job. Comment down if you have any question. So once again, like, share and subscribe. Thanks for watching.